Hi students, we are working on the 2016 question number 2 test. The topic is position, velocity, acceleration. The first thing I did was I took the velocity that they gave me and plugged it into my calculator in y1. I also noticed they told me the particle's position is x equals 2 at time equals 4. So I rewrote that as x of 4 equals 2. At time 4, the particle's position is 2. Alright, part A, at time equals 4, is the particle speeding up or slowing down? They're using the word speed. So is speed increasing or is speed decreasing? So remember, speed increases when velocity and acceleration have the same signs. And speed decreases when velocity and acceleration have different signs. So the question is, at time equals 4, do velocity and acceleration have the same signs or different signs? And let's go ahead and see how we're going to figure this out. Well, all I need to know is what's the velocity at time 4? And what's the acceleration at time 4? Now, this is in y1 in my calculator. So to type this in really quickly, I'm going to use my hotkeys, alpha trace, and then I'll put a 4 in there. And that's going to be the quick, easy way to get this answer here. However, you could just type this out and put a 4 there. So I'm going to go ahead and say alpha trace, plug in a 4, and here I get 2.9787. And now I need to know acceleration. Now acceleration is the derivative of velocity. But I don't want to take the derivative by hand. I'm going to let my calculator take the derivative. So I'm going to use math 8, tell my calculator to take the derivative of what's in y1, so the derivative of what's in y1, or the derivative of velocity, and then tell it to plug in time equals 4. And that answer is going to be what's going here. So, because I don't want to take the derivative by hand when I don't have to. So I'm going to hit math 8, take the derivative of what's in y1, alpha trace, what's in y1 at time 4, and I get the acceleration is negative 1.164. 0. This is, velocity was positive, greater than 0, acceleration is negative, less than 0. So if the velocity and acceleration have different signs, and speed is decreasing. So I'm going to say speed is decreasing at time equals 4 because velocity and acceleration have different signs. And all this together is my answer for part A. Alright, part B says find all times on the interval 0 to 3 when the particle changes direction. So if you just did the previous question that I had listed, the 2013 question, it's going to feel very similar. So anyways, go ahead and look at what we have to do here. Alright, so this is part B. When velocity is greater than 0, a particle is moving to the right. If it was moving up or down, it would be moving up. When velocity is less than 0, it's moving to the left. And when velocity equals 0, a particle is at rest. So a particle changes direction when it goes from right to left or left to right. So all we really need to do, or from velocity goes from positive to negative or negative to positive. So all we need to do is make a sign chart of velocity to figure out what's going on. So I plug this in y1 in my calculator, and I'm going to graph this. When I graph this, I'm going to make my window go from 0 to 3. And let's see what the graph looks like. So this is velocity. I'm graphing this from 0 to 3. We got 1, 2, 3, and the graph looks something like. So right here is where it hits 0. So if I find out where that is, I hit second calc. So second calc and then 0. I'm going to let my calculator find the zeros. I go to the left bound, I go to the right bound, I hit enter, and I get this is 2.7074. And now let's take this and make a sign chart of velocity. So velocity, only from 0 to 3. Here we have the number 2.7074. And notice velocity is above the curve over here. It has positive values, and below the curve here it has negative values. So this is my sign chart of velocity. So velocity is positive, it was moving to the right. Velocity is negative, it's moving to the left. So right here is where the particle changes direction. Make sure you're labeling your sign charts. So I would say the particle changes directions at time equals 2.7074 because velocity changed signs. That's it. You could say velocity went from positive to negative, but velocity changes signs is enough. When velocity changes signs, a particle goes from moving right to the left or left to the right, depending on the situation, and that's what they want. All right, so that's it for part B. Let's go look at part C now. All right, part C asks, what's the particle's position at time equals something? Find the position of the particle at time equals 0. Well, good news. We know where the particle is at time equals 4. Remember, the area underneath velocity gives us the net change in position. So, let's just go with our basic way of dealing with this. We want to know the position at time 0. We know the position at time 4. Now, if you're comparing these on a timeline, time 4 comes after time 0. So we're looking for the initial, and we have the final. So remember, if you have the final position and you want to work backwards and know the initial position, you take the final position minus the net change in position. The area underneath velocity gives the net change in position. And we want to know how much does position change from time 0 to time 4. Now, when I go to type this in my calculator, I'm going to use x of 4, I'm going to use the number 2. My initial position was 2, and then the area. And when I get to v of t, you can either type out the whole equation, or you can use hotkeys. I have this in y1 in my calculator. So I'm just going to type this in and get the answer right. So again, the area underneath velocity gives the net change in position. So this will tell me how much position changed from time 0 to 4. So 2 minus math 8. Oops, not math 8. 2 minus math 9, sorry. From 0 to 4 of alpha trace. What's in y1? And I get my answer of negative 3.8150. And that's it. That's part C. Part D, super easy. Find the total distance traveled of the particle from time 0 to 3. Total distance traveled is our special word. Integral absolute value of velocity. The absolute value of speed gives total distance traveled. This is my formula for total distance traveled. We want to know how far did it travel from time 0 to 3. Integral, absolute value of velocity, 0 to 3. When you get to v of t, you can use the hotkey, y1, or you could just retype all of that in. So I'm going to type in my calculator math 9 to get this part from 0 to 3. When it comes to the absolute values on my calculator, I hit the math button, and then I go over 1 to numbers, and then I hit enter on ABS. And then again, I want to type in the whole equation, but I'm going to use the hotkeys alpha trace and see what the calculator gives me for my final answer. And I get 5.3012. And that's it. Hope you enjoyed the question. Bye.